In this video, we're going to talk more about symbolic logic, this time focusing on a couple more terms in our list from the previous video, so that would be conjunctions and disjunctions. So the question we're going to answer is, what are some ways we can combine propositions? How does that affect truth value? To review what we talked about in the last video, a proposition is a declarative statement, in other words, not a question, not a command, that can be either true or false. Reviewing some keywords from the last video, our previous video talked about proposition and negation, which is the not operation. And we briefly talked about a truth table for negation. In this video, we're going to focus on these last three bullet points: conjunction, disjunction, and exclusive disjunction. The symbols we learned for each of these in the last video are that conjunction is this wedge symbol between our propositions. Disjunction is this V symbol between the two propositions. Negation is either a bar over your proposition or this sideways backwards L in front of or before or to the left of the proposition. We're going to also talk about exclusive disjunction, which is exclusive or, and that's denoted by P, XOR, Q, or this circle plus, and there's other symbols that people use. In our textbook, for example, you're going to see P underlined V, Q. So what are the truth tables for and or? Notice in this truth table we need 4 rows, because it's not just about whether P is true or false, it's about whether Q is true or false and getting every possible combination of those two truth values for each of the 2 variables that we have. In other words, this truth table is telling us when P is true and Q is true, P and Q is true. P or Q is also true. If P is true and Q is false, or similarly if P is false and Q is true, the outcomes are going to be similar. We're going to have P and Q is false in either of those instances. We're going to have P or Q is true in both of these instances. If both P and Q are false, we're going to get that P and Q is false, P or Q is also false. Notice AND has 3 falses and 1 true. P or Q has 3 trues and a false. This is the inclusive or the disjunction. And so what we have is that the logical AND is kind of more restrictive, more exclusive. Let's take some English language examples and break them down and try to express them in symbols and understand how to use what we've learned so far. So I passed the course and you passed the course. Okay, so let's try to write this in symbols. Let's say that I passed the course is P. Then let's say that you passed the course is Q. What we have then is, this first example is P and Q. Next one, you passed the course. either you pass the course, which actually we called that Q earlier, or I pass the course. Now notice that these two things can be happening at the same time. There's no reason that you passing the course means I can't pass the course or vice versa. So what we have here, if I translate this in the order it's written into symbols, I'm going to have Q or P. I'm just trying to literally translate this sentence in the order it's written into symbols. Now this last one, we're going to just read it first before we try to translate it into symbols. Notice it says, either I pass the course or I fail the course. Notice that both of these are exclusive to each other. You can't pass the course and fail the course. It's not possible. It's kind of like when you're asked, do you want fries or salad with your meal? Like, you want fries or you want salad, but not both. You can't have both unless you want to pay extra or something. So the logic we're talking about in number 3 is the exclusive or. So let's label our statements. So I pass the course, we'll call that P, and we need a new letter for I fail the course because we haven't encountered that statement yet. So I'll call that R. And as we mentioned, this is an example of exclusive OR. So I'm going to put P exclusive OR R. And that's how we translate that third example into symbols. Now let's look at some mathy examples. We have pi is less than 3 or 2 is less than pi. So what we're going to do is we're going to try to make sense of this. So let's see, this first one here can be our P. And the second one, we'll call it Q. So we're redefining what P and Q are. It's new set of examples. So what we have is, if we write this out, we get P or Q. But this isn't really telling us much. We already have math symbols here, so what we really want to write is pi is less than 3, and I'll put that in parentheses just so we know and think of that as a single entity, or 2 is less than pi, and I'll put that in parentheses as well. Okay, let's talk truth values for a moment. Pi is less than 3, that's false. 2 is less than pi, that's true. I have false or true, that turns out to be true according to the truth table we looked at on the previous slides. What about this second example? We have pi is less than 3. Notice that's not the same statement as pi is less than 3. And it's not even the negation of p, right? Because as you recall, the negation of pi is less than 3 would be pi is greater than or equal to 3. So be careful. This here, pi is greater than 3, is not the negation of p. You need to be careful about that. So we need to give this a different name because it's a completely different statement. We'll call it R. So we have the statement R, which says pi is greater than 3. And we have the statement pi is less than 4. We'll call that S. Pi is less than 4. Okay. If I just purely use symbols, it would be R and S. But again, that doesn't say much. So I'm going to write this as pi is greater than 3 and pi is less than 4. So what do we have here in terms of truth values? Pi is greater than 3. This is true. Pi is less than 4. This is also true. We are connecting two true statements with and, so the overall truth value of the whole statement is true. All right. Now, what is going on with this next statement? 3 is less than pi, which is less than 4. This is a conjunction in disguise. This is an example of and. This is saying exactly the same thing as number 2. Okay, because notice it's saying 3 is less than pi. 3 is less than pi means the same thing as pi is greater than 3. In other words, this here is the R part. And then it's also saying pi is less than 4. So it's saying both of those at the same time, which means it's saying that we're saying both of them. We mean both of them. So R and S. 3 is less than pi and pi is less than 4. So it's the exact same situation as number 2, which means it will also be true for the same reasoning as we did over here. To sum up, we talked about logical connectives, the symbols and words that can represent them. We talked about how to make the truth tables for logical connectives. And we're going to build a lot more on this idea of truth tables. We talked about inclusive OR versus exclusive OR. And then we talked about compound inequalities, representing them as conjunctions and disjunctions, especially that last example where it doesn't look like it's necessarily a conjunction, but it actually is.